figured. That sounded kind of intelligent, didn't it?
Yeah. Quite easy.
Okay, well these are soybean plants, and soybean is one of the most economically significant legumes that are grown around the world. A huge source of food and biofuel, and also they're used as a feedstock for a lot of animals like sheep and cattle. One of the defining features, of course, is that they form pods. We've all seen the common pea pod, and soybeans have the beautiful pods as well, full of their seeds. But another defining feature that most legumes have in common is that they're able to enter into a symbiotic relationship with a special nitrogen-fixing bacteria called rhizobia. And these rhizobia are able to infect the plant, and the plant welcomes this infection, and in fact it goes as far as to build a new house or a new organ for the bacteria to live in. And this is called the nodule. And inside the nodule, the bacteria will fix atmospheric nitrogen for the plant. And this is really important because a plant can't normally access atmospheric nitrogen. So the plants are basically giving it a source of available nitrogen that would otherwise be unavailable. And this really helps the legume plants to outcompete other plant species when it's growing in the environment. It's also terrific in agriculture because it means that farmers are able to apply less nitrogen-based fertilizers in order to have a healthy crop yield. And that's really important because nitrogen fertilizers are quite expensive and are getting more and more expensive to manufacture and apply. But also they pollute, often pollute from the nitrogen fertilizer that's not taken up by the target crop plant, entering the atmosphere in the form of greenhouse gases, or entering the waterways and causing pollution, algal blooms, and that in lakes, streams, and even the ocean. And over here, what we've done is an experiment using different mutants or different varieties of soybean plants that we've then mixed with different concentrations of nitrogen. So in this first category here, we have a wild type parent soybean plant, which is a normal cultivar, which is actually grown in America as a food source. Over here we have a mutant, and this mutant is a clone of this parent, except it has a mutation in that one gene that causes it to form too many nodules or to excessively nodulate. So this is what we call a supernodulation mutant. Over here we have another line which came from the same parent, but it has a different gene that was mutated, and this mutated gene is responsible for the plant being able to recognize nitrogen-fixing rhizobia bacteria in the soil. Because it can't recognize those bacteria, it never forms nodules, and as a result, it doesn't get the benefits of nitrogen fixation. So in this particular 3 pots that we're growing here, these plants weren't provided with any nitrogen fertilizer, just with rhizobia. And you can see with our wild type parent and our supernodulating mutant, they both have nodules forming. Even though we haven't dug up the plants, we know the nodules must be there because they're nice and green. When we look at our friend here, though, who has the mutation that prevents it from being able to recognize the rhizobia bacteria, we can see that it's quite pale. And the reason it's quite pale is it's nitrogen deficient. The reason it's nitrogen deficient is because it doesn't have the nodules forming and isn't getting nitrogen fixation from its symbiotic partner, the rhizobia. Okay, so with this wild type parent plant and the supernodulating mutant plant, you can see at this stage they look fairly similar in stature, and they're both fairly green in color, and they're looking nice and healthy. But the difference is, because this plant is supernodulating and isn't controlling the number of nodules that it forms, it's using up a lot of its resources to form and maintain those nodule structures. Over time, this can cause an inhibition in the ability of this plant to grow and be as vigorous and sometimes even to yield as well as its parent plant. So although supernodulation is great for increasing nitrogen fixation, it doesn't always make it a desirable trait for agricultural purposes. So here we have the same 3 varieties that I was just showing you earlier. This is the wild type parent, this is the supernodulating mutant, and this is the non-nodulating variety. And they were all grown in the same way, the only difference being that they were provided with 10 millimolars of nitrate. And that nitrate has really caused the leaves to green up and give these plants this big bushy appearance that they have. Nitrate is one of the main components that plants need for their growth and development. And so by providing them with that, it's fantastic for getting them to get so big and to grow so well. But as I say, nitrogen-based fertilizers are quite expensive and can often pollute. And so if we can get the plant to provide its own nitrogen through nitrogen fixation, that helps significantly to save the farmer money for having to purchase and apply these nitrogen-based fertilizers, but also the environment for having to avoid some of those bad things. Edit that part, how about that?